Dear students, today we are going to discuss about tensor quantities. So first of all, we will discuss about the covariant, contravariant and mixed tensor. So let us look what do you mean by covariant tensor of first order. So if n quantities where tensor is always defined in the form of quantities. The if n quantity is written like this, that is subscript ai, where I varies from 1 to n in a coordinate system xi, where I varies from 1 to n are related to n other quantities. Why other quantities? Because always we define the tensor with the help of component or with the transformation. So for that purpose we have to define other quantities like a bar j. J is the subscript where varies from 1 to n in another coordinate system x bar j. Then we can define a bar k is equal to summation over s equal to 1 to n del x bar s del x power s divided by del x bar k a s. S is this subscript. Okay, so where k varies from 1 to n can be written using summation convention as this: a bar k is equal to del x power s divided by del x bar k a s. Here a s are called component of a covariant tensor of first order first rank. Okay, similarly covariant tensor of higher rank or higher order. So in case of higher order, you can define this key if n square quantities where aij subscript where I and j varies from 1 to n of a coordinate system xi, then are related to n square other quantities, say a bar lm. Then you can define here a bar rs is equal to del xp del xq del xp divided by del x bar r and del xq divided by del x bar s apq. So you can mind here here this in the covariant tensor, this is here already you can look the subscript r and s, and here in the denominator term del x bar r del x bar s, and pq is which is known as the component of a covariant tensor. So just you look here the indices in the numerator del xp and del xq. Okay, so this is called a PQ are called component of a covariant tensor of rank 2. Now similarly you can define the contravariant tensor of higher rank. The if n square quantities, but here is it is superscript aij, where ij varies from 1 to n of a coordinate system xi. Here also this is superscript are related to n square other quantities a bar superscript rs and xi, where rs varies from 1 to n in another coordinate system x bar j. Then you can define a bar rs is equal to, same here you can look at this quantity is in the numerator del x bar r and del x bar s, and this is in the here component of del xl del xm. Okay, so differentiation you can observe easily in the between covariant tensor and contravariant tensor. Here ALM are called component of a contravariant tensor of rank 2. Now similarly you can define the higher order in both covariant and contravariant. Here I am defining the contravariant. The if n power 5 quantities ijklm, ijklm varies from 1 to n of a coordinate system xi, where I varies from 1 to n are related to x power n power 5 other quantities, say a bar p q r s t. This is also 5 components. The xi, where this p q r s t varies from 1 to n in another coordinate system x bar j. Then you can say here then you can say ki a bar p q r s t is equal to, then you can write in the numerator del x bar p del x bar q del x bar r del x bar s del x bar t, and in denominator you can see from here I j k l and m. So here a power I j k l m are called here this quantity this a power I j k l m, this quantity are called component of a contravariant tensor of rank 5. Similarly, if required rank 6, 7, 8, you can write. Okay, to any rank you can write similarly. Now, just you mind what is the covariant and contravariant, and now we are going to discuss about mixed tensor. The mixed tensor is nothing but it is a tensor which is both contravariant and covariant nature. How it is? If n square quantities of a k l, where this is superscript and subscript both, the AKL of xi, where I varies from 1 to n, are related to A bar QP of x bar j, where j varies from 1 to n, then A bar QP is equal to del x bar p divided by del x bar power k and del x bar L divided by del x q AKL. So here A bar P QP are said to be the component of mixed tensor of rank 2 are of second order with one contravariant and another of covariant in nature. Okay, the even power 5 quantities of AQST KL of xi I is equal to 1 to n are related to A PRM Ij of x bar j, then you can define like this. And here of course AQST KL are said to be the component of mixed tensor of rank 5. Okay, so both superscript and subscript, so this is called rank 5 are of 5 order with कहाँ 3 क्या है, 3 are contravariant and 2 are covariant in nature. Okay, so now after this we have to study about symmetric and schizometric tensors. So let us look what is the symmetric and schizometric tensor. A tensor is said to be symmetric with respect to two contravariant or covariant indices if its component remain unaltered upon interchange of the two indices. Thus, the tensor A power KL and ANP, here this is superscript and this is subscript, are symmetric if A superscript KL is equal to A superscript LK for LK and A subscript NP is equal to A subscript PN for NP. In general, any tensor is called symmetric if it is symmetric with respect to any two contravariant indices. So here you can write Aij is equal Aij superscript and then subscript KLM may be written as AJI superscript and KLM. और अब दूसरे तरीके से क्या लिख सकते हैं, Aij superscript and subscript KLM. Here in KLM you can change LK. Or in third form Ij you remain same and you again change here this KL KLM or last term LM you can change ML. Okay, so this is about the symmetric with respect to contravariant or covariant indices. Now a tensor is said to be schizometric with respect to two contravariant or covariant indices if its component change sign on interchanging of the two indices. How? Thus the tensor Aij is schizometric if Aij is equal to minus Aj for I and j. In general, any tensor is called schizometric if we can write Aij KLM is equal to minus Aij KML. Okay, that is called symmetric. Now we will learn what is the fundamental operation with tensors. Like addition, the sum of two or more tensor of the same rank and type is also another tensor of the same rank and type. So let us suppose one tensor you have taken here, this tensor A bar Ij and another is B bar Ij. Then how you can write this contravariant tensor? So you can just same type of the tensor first condition should be कि वो दोनों rank और type क्या होना चाहिए, same होना चाहिए. Now you can add A bar Ij plus B bar Ij and you will get a new tensor, that is C bar Ij. C bar Ij, of course, if you want to define C bar Ij, then you can write del x bar I over del x k, del x bar j over del x l ckl. So both the tensor are after addition also you got the same type of the tensor or same order of the tensor. तो same rank same type का tensor आपको मिल गया, एक नया tensor मिला, that is C bar Ij. Similarly, you can do the subtraction also. The difference of two or more tensor of the same rank and type is also another tensor of the same rank and type. And we may write A bar Ij minus B bar Ij is equal to C bar Ij. Or A bar Rs, this is contravariant and this is second order covariant. A bar Rs minus B bar Rs is equal to C bar Rs. तो मिक्स टेंसर भी आप ले सकते हो सेकेंड ऑर्डर का. A bar QP minus B QP bar is equal to C QP bar. In this way, you learn about the